in study hall. You had the questions 1 through 15.
Oh, yeah.
Odd.
I did
Like,
it. I
Chris,
did
you
it.
went over this
I did it. I just
so
forgot.
many times.
I did. I just forgot.
Like 3 different times.
I just
Okay.
forgot that.
Welcome, Jamie. Welcome, Quentin. If you end up watching this later for it. So let's go ahead and have your homework out. If you're doing anything from this chapter or the chapter before or the chapter before that, my goal is to hopefully get through chapters 7, 8, and 9 today. So that's the goal. May or may not make it, but that's the goal. So if you want to review something from those chapters, I would recommend that for it. All right, I'm gonna go ahead and check homework. As long as it's not distracting you or other people. Sweet. Oh, Jimmy and Quentin, be sure to send me a photo of Lab 9 at some point today, please, as soon as you can. Alright, so let's go ahead and let's go over it. So you had for chapter 7, chapter 7, you had the questions 1 through 15 odd. Alright, what's your question?
So like, say if you were like missed today, and you said, oh, okay, I was bringing the lab tomorrow. Can you not do that? Will that be like 9 to 10 or something?
It depends on what it is. Like for most, like keep in mind, if you're sick today and you want to bring it in tomorrow, okay, that's fine. But if you just decide, okay, something happened and I'm just not coming to school, but I'm going to watch the videos instead, then you can send it that way. What?
You can just say, alright, I just watch the videos then?
No, parents have to like email in permission for stuff like that. Like if they're worried, like if you've been exposed to like COVID or something, and they say, hey, we're going to go mobile temporarily, they have to email ahead of time to let us know. Or email if they find out, oh, you know, something's happened, we gotta go get a COVID test or something. So I have to email in and let the school know, so that way I'm going distance learning for a little bit. Alright, so number 1. As the wave's frequency increases, what happens to its wave, as the wave's frequency increases, what happens to the wavelength? Alright, Ethan.
The wavelength gets shorter.
Good job, or decreases. Number 3, give the speed of light in a vacuum in meters per second to 3 significant figures. They got specific in this one. Alright.
3.00 times 10 to the 8th power ms is the speed of light.
Good job. Number 5, state the quantum theory of light. That was a very good complete sentence.
What's the difference between the speed of light and the speed of light in a vacuum?
Well, remember, okay, so the speed of light in a vacuum, there's nothing interfering with it because there's particles.
So it's faster.
It's at its fastest speed. Nothing is faster than light in a vacuum. So we can't go faster than the speed of light. At least for as of right now, we can't go faster than the speed of light. And even weird stuff starts to happen. We talk about this in physical science, where like time starts to like slow down and stuff as well. Like weird stuff starts. Okay, you don't have time to get
Alright,
to it
so
all.
you know when like someone like speed warps in Star Wars?
Yes.
Is
That
that
would
pretty
not-
much what that is? They're going faster.
They're going faster in the speed of light in the movie, but in real life,
That would
whenever they
never
start
work.
to get kind of close, something like that, weird stuff starts to happen to your mass and to your volume and time, basically.
Is that
Talk
because
about
like other dimensions possibly?
it's one of the, they think that maybe the spiritual dimension, there's theories that the spiritual dimension, like demons and angels, can move at the speed of light, and that's how come we don't see them, is because they can just warp there, basically. But again, like, we don't know. But nothing can move faster than the speed of light physically. Like, that is fast as you can get. That is as fast as we can get. As of right now, and with current technology, that's as fast as we can go. It doesn't seem like you can go faster than that because of weird stuff that
What would
happens.
happen if someone crashed into something at the speed of light?
Massive explosion. The speed of light
Even
is
if it's like
super fast.
a mini particle.
Well, keep in mind, light is moving at the speed of light, and so photons are hitting you all the time at that
Or
speed.
like,
You just
say, like
don't.
a rock. Would it make it
A
actually?
rock hit it? That would hurt.
It would go through you.
It might, yeah, because I mean, it's 3.00 times 10 up to the 8.
Yeah, that would go
That's
through you. I'm
incredible.
just saying,
You
like,
would
would it make
kill
an explosion?
Might like shatter your skull.
I'm talking about if it hit the ground.
I would say yes, loosely, depending on the mass of the object, loosely. But we gotta get back into this. That was a very good complete answer for your number 3. Number 5, state the quantum theory of light. Alright, Ethan.
It states that light consists of tiny bundles of energy called photons.
Good job. Alright, number 7, distinguish between a continuous spectrum and a line spectrum. Alright, Chris.
Line spectrum only has specific colors, while continuous spectrum has them all.
Good job. It's all the visible colors of the wave. So basically, it's like a prism. Whenever you shine light through it, it's all the rainbow. While if you were to electrocute certain types of elements, you would see them as certain colors. All right, number 9. Define the ground state. All right, Ethan.
Ground state is the lowest energy state.
Good job. Do you remember what?
Same words.
Yeah. Do you remember what model started using the ground state? I haven't talked about models in a while, but you might
Bohr.
step back. It is the Bohr model. Good job.
Born or
Number
born?
Bohr comes later. This is the Bohr model. Alright, number 11. Distinguish between an orbital and the electron cloud model and an orbit in the Bohr model. Alright.
Orbitals are region of space in the cloud model, while Bohr says that they don't move. Is what I have.
Okay, close with the idea of they don't move, but it's the idea of an orbit is like a line, and so that's the Bohr model. Well, an orbital is a region, because remember they're moving up and down, and so because of that, it's not just a straight line. Alright, number 13. What is a quantum number? What four quantities of an electron do the four quantum numbers describe? So you got a more specific one, Ethan.
It is the four numbers that describe the electrons, or energy level. Principal describes main energy level. Subshell describes the shape. Magnetic describes orientation in space. Spin quantum number describes clockwise and counterclockwise.
Good job. So way to list off all four as well as what they describe, and you do need to know that again for the exam. So just make sure you go back and relearning it. Number 15. What are the valence electrons? We've talked about these so much. And what is the maximum number of valence electrons that an atom can have?
Valence electrons are the outermost electrons, and the max an atom can hold is 8.
Very good, complete sentence. Alright, do you have any questions about that? Alright, we didn't quite finish up yesterday's homework, so go ahead and get that back out so that we can talk through the answers for it. No, remember we got through part of it and then I ran out of time because of the lab. So we left off on question number 6. We got through part of it with the idea. Yeah, I think we got through C. I think barely maybe we were gonna go. So let's go ahead and let's go.
We ended on me and I had B.
What?
We ended on me and I finished D.
Are you sure?
Yeah.
Okay,
Yeah.
we can do that. Alright, so make a note for that one for number 6 for saying which one is larger. Alright, so D. Are you sure we did C? Let's do C again. I do not remember talking about C at all. Alright, so C. Alright, Chris, what do you have for C?
H negative is bigger because it has more electrons.
Good job. Alright, D. What do you have for that one, Ethan? This one's kind of a tricky one though.
BE2 plus is less, or is closer, or I don't know, we're asking. BE2 plus.
Alright, so let's talk through. So Jamie, you can't see with the correct table, so I'm sorry, I might have to look in your book quick. Alright, what?
Is he right?
We'll talk about it in a second. Alright, so H negative. So H negative, what does that mean?
That's what I had.
What does H negative mean?
It has the one extra electron. So
It has
it's
one
it's
extra
a hydrogen with
electron.
2 electrons.
It says what?
That's a hydrogen with 2 valence electrons.
Yep, so what does BE2 plus mean?
It's a BE with minus 2 electrons.
So how many electrons does BE2 plus have?
0. If it has, just
4.
BE2 plus if it starts off with 2.
Alright, starts off with 2 and that outermost shell. So how many
Oh, that's 2.
electrons? Yeah, so if it's lost 2,
And
that means that means there's 2 remaining. Because remember, beryllium, because it's number 4 in the periodic table, that means a normal atom starts off with 4 protons,
Yeah,
and if it's neutral, then it starts off with 4 electrons.
Kinda whack.
What?
Kinda whack.
It is a little bit weird. So it kicks off 2. So how many electrons does it have remaining? 2. How many did hydrogen
They're
have?
equal.
Yeah, they are equal. That's what comes. This one is actually kind of a trick question. So it's asking you which one is larger, and so because of that, which one has more protons if they have the same number of valence
Neither.
electrons? Which one?
Neither.
Which one has more protons? If they have the same
BE.
number. What? BE or
Beryllium.
beryllium. So which one will the remaining electrons be more attracted to?
BE.
BE. But yeah, they will not be that weird on the exam. I will not give you one that weird, but that one is a bizarre one. And I actually have it marked in my book that this one's kind of a tricky one. So for this one, the hydrogen negative is the slightly larger one, but you will not get something that weird on your test. Alright, anyone have any questions about that one? Alright, number E, CA or AS. Alright, which one is larger?
CA is larger.
Yep, why?
It's a larger cloud.
Yeah, it's also farther left, so if you're looking at CA and AS, so this one is farther on the left side for it because they're on the same period. So because this one is farther left, that means, remember the metals, they don't want them as much as the non-metals. Alright, you got it?
Ye.
Got it, awesome.
I got it right. So.
Good job. Alright,
Okay.
F for Ethan. Alright,
What?
do you have? I used the letter F.
You
AU.
said F for Ethan, like F. Ethan starts with an F.
I know. It's one of those, let's come on, just going down the line. Alright, so CU, so copper plus, or AU. Do you remember what AU is?
Gold.
Good job. So, for A plus. Which one is larger?
AU.
Good job. Alright, does anyone have any questions about that one?
No.
Alright, G. I also have this one as marked as a slightly tricky one, so
RB.
I'm sorry. Which one?
RB.
Alright, so
I don't
you.
want. No, I know I'm wrong.
Alright, so SR2 plus and then RB. Alright, so SR.
Let's just say SR2 plus.
Alright, nope. Alright, so SR2 plus, what does that mean?
It's SR minus 2 electrons.
Good up. Alright, and then rubidium 1 plus. So what does that mean?
It's minus 1.
It's minus 1. So how many electrons do they both have then?
1, 2.
Well, they have the equal number of valence electrons.
Okay.
Okay, so which one has more protons at that point?
SE.
SE?
SR.
SR. So because of that one, which one will be the larger one?
SR.
If it has more
No,
protons.
the one I got, the one I said, RB.
RB? It is correct. Right. But yeah, that one is hard. That one again, that one's a little bit trickier. I will not ask you something that specific on the exam, but it's a more of a trick one. I have those two, D and G, marked as tricky ones in the textbook, so will not be that hard on the exam. But if you figured it out, good job, Jamie Quinn.
I got it right because I guessed.
That also works. So good job guessing ability. Alright, number H. Iron 3 plus or iron 2 plus. Which one is larger?
2 plus.
2 plus, because there's more electrons with the same number charge. Alright, anyone have a question about that one?
No.
Alright, letter I.
N.
Which one?
N.
Good job, that is correct. Why?
1 electrons.
Yeah, and it's farther left. Alright, BR or I?
I.
Why?
Farther left. Towards the left. I don't know what the other one was. But
Farther
what-
down?
The what?
Alright, BR or I?
I.
Why?
Cause
Is it farther down? Yep, that's right. Alright, anyone have any question about that? Alright, you can go ahead and put that away. Alright, I actually have worksheets for you to do, so it'll help you to start getting ready for it. So, try to see how far you can get, probably in about 5 to 10 minutes. It's not a race, so don't try to
It's a
get
race. No, it's a
speed
race. It's a
with it
race.
for it. Try to get it correct too, though. Don't sit there and be like, I have to beat Chris or I have to beat Ethan. Try to do it. So, Jamie, if the gentlemen are going too fast and you want to pause the video because you want to slow down and do it, that is fine for it. But it is not a race, gentlemen. So, try to see how far you can get for it in about 5 to 10 minutes loosely. So, for this question, so Jamie as well for this one, that this is problem set number 1. So, for this one, you are describing the Lewis structure, or what is the geometric shape. Alright, so what is the geometric, so, for this one, I did not say draw, oh, I did say the top. So, these are the problems, draw out the Lewis structure. What's a Lewis structure, Chris?
Tetrahedral.
Yeah, something like that. And then number 1, what is geometric shape? So, say, is it polar or non-polar? And what intermolecular forces affect it? So, you're answering a bunch of
How
different
do we
stuff.
know what intermolecular force affects it?
Alright, so what intermolecular forces affects all of them? So you should write this force right off the bat. Yeah.
where's GE at?
So you should write London right off to the side for that one. Now, dipole affects which ones then?
Polar.
Polar. So you should only write dipole next to the polar ones. And then if you have a hydrogen bond, it has to be hydrogen bonded to
Fluorine, nitrogen, or
CI.
oxygen. And so because of that, you have to look and see, okay, first of all, what shape is this? Is it polar or non-polar?
NF and oxygen. Yeah.
Oh, for number 3, I underlined C because that's the middle one. So like how your lab did, I'm just telling you, hey, that's the middle one for you. This is a good practice over a bunch of stuff for
Let's
chapter 9.
say oh, we do have to say which it is.
So draw the Lewis structures because you're going to be asked stuff like this on your test. So make sure you know how to do it.
I don't want that. I hate kids.
automatically write London next to every single one of these.
Is it possible that all can affect one of them?
Hmm?
That's right, alright, I mean, that's one of them there is.
Alright, you can go ahead and write your Lewis structures up on the board. I'm gonna slide it up to the ceiling. Sorry, Jamie.
I'm about to.
Alright, so Chris, why don't you draw the Lewis structures 1 through 3 over here, and then Ethan, you can draw yours over here.
1, 2, 3, him, and I have 4, 5, 6.
He has 1, 2, and 3, you have 4, 5, and 6. So whenever you're done, you can draw them. I'm telling you right now, one of yours is wrong, so you might want to double check it.
Is that right?
That is correct. Keep on fixing it.
What about all the stuff that goes with it? Are we just lower structure?
You can draw just a little structure. I'll use that structure. We'll talk about the shape in a
After
second.
this, we're gonna review.
Yeah.
Ooh, that kinda hurt it.
Heard it. Sniff?
Hmm?
Did you sniff?
No. No, I've cut it.
Feet down.
Well,
Don't need to burn any more brain
I
cells.
thought Melvin was gonna get a demerit.
Is he not here either?
Huh?
Is he not here either?
I thought he was gonna get a demerit.
oh, in class?
Yeah, discipline.
Disobedience.
Was it in first house?
I'm John. Yeah, we don't have first hour tomorrow.
Kinda crazy. What's my back doing?
Even like, he can still hear you.
My back looks so weird.
But move it over.
Yeah, but like, someone else didn't go really straight. Again, I have like this weird thing, my vertebrae pops up in the middle.
And I think that's normal a little bit to a certain extent, but it's more exaggerated.
Like my chest.
Yeah, mine is more exaggerated than mine. I was born dumb.
You were not. No.
Am I wrong on one?
How many dots do you have on a carbon? That's an awful lot of electrons.
1, 2, 3, 4, 5, 6.
Right, remember, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 right now, is how you have it written.
lines.
What?
There's the lines.
Well, you still have 2 dots. Remember, it's one here, and there's another one being shared here, that's what a single bond represents. Or a double bond.
Alright.
So, 1, 2, 3, 4, 5, 6, 7, 8, but is each sulfur happy?
Go back.
There you go. Alright, you go down.
Ooh, test.
Nope. Alright, so, zoom it back down now. We'll get back to giving button. Alright, so this is Chris's number 1. Alright, so this is the correct Lewis structure. Scroll up to this one. Alright, what shape is this?
Tetrahedral.
This is tetrahedral. Is it polar or non-polar?
Non-polar.
It is non-polar, so what force is affected?
London.
Just London. So this one is non-polar. Why is it non-polar?
Is this the same all the way around?
Yeah, it's the exact same all the way around for it. So iodine would probably pull it slightly towards it because iodine shows up with how many valence electrons?
7.
7. So it'll probably pull them slightly closer towards it. Since it's all the way around, it'll be non-polar. Alright, so what is this one?
Linear.
This is linear. Alright, polar, non-polar.
Polar.
This one is polar. What force is affected?
London. Hydrogen. Dipole.
This is correct. It is all of them. So this one has all 3 of them. Alright, do you have a question about this one?
No.
Alright, good job figuring out this one. Forgive me. Bars like smack.
Ouch.
this one because oxygen gets a double bond. Why?
Cause it wants more.
Yeah, because oxygen starts with how many?
6.
6, so it has to have 2 more added to it. That's why this one is a double bond. Carbon is satisfied because remember, there's one of carbons here, 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 and here, and then it's basically borrowing or sharing 2 of oxygen, 1 of chlorine, and 1 of hydrogen. So this is the correct shape for it. Alright, so what shape is this?
Trigonal pyramid. Trigonal planar.
Planar, because remember, there's no other electrons, so it'll split up each other as much as possible. Alright, polar, non-polar?
Polar.
Polar
No,
what?
well, yeah, polar.
It is polar, because it's not the same all the way around.
Dipole, dipole.
Dipole, dipole. Alright, let me make sure.
London.
I'm
And
gonna
London.
slide my
I said London.
screen over. You.
Did.
Alright, Ethan, this is for number. Make sure she can still see. Yeah,
4.
Okay. So, this is number 4, and you were correct. This is the correct Lewis structure. Alright, what shape is this?
Tetragonal pyramid.
What is it?
Trigonal pyramid.
Trigonal pyramid. Alright, what type of bond is here as a side note? Just checking.
Oh, single bond.
Okay, that's what I wanted to make sure. So, just be careful whenever you draw it, that you don't want to look like you have too many electrons. So, single bond, single bond, single bond, and then you're right, you do look like electrons. Alright, you have any questions about this one? Alright, this is number 5. Alright, so, what bond is here? Because we're giving an extra dot.
Single.
It's a single
Sorry.
bond. Yeet. Single bond. Yeet. Alright, so, and are these dots?
Good. Yeah.
Just
Draw
making
Morse
sure.
code.
Alright, so what shape is this?
Angular.
It is angular. Good job. Alright, so I didn't ask you about this one. So polar, non-polar?
Non-polar. Polar.
Polar. So what force is affected?
Do what?
What force is affected?
Number 4.
For number 4.
London.
London
Dipole.
and dipole. Alright, now for this one. What force is it? So is this one polar or non-polar?
Polar.
It is polar. So what force is affected?
London. Dipole. Hydrogen.
What?
Hydrogen's bonded to fluorine, oxygen, and nitrogen? Hydrogen's bonded?
And nitrogen, boron, and oxygen.
But
Oh, all those have to be together?
no, it has to be hydrogen bonded to it. Who's bonded to fluorine?
Hydrogen has to be bonded to fluorine or oxygen.
This is
For it
like,
to be hydrogen?
yeah.
Yeah,
So if it's a
yeah.
hydrogen bond, it has to be hydrogen specifically bonded to nitrogen, oxygen, or fluorine.
Oh, okay.
It's okay. Alright, so this one just has London and dipole.
Since-
Alright, so what? Alright, so this is the correct Lewis structure for this one. Let's talk through this one, Ethan. Alright, Ethan, how many does carbon start off with?
4.
4. Alright, how many does sulfur start off with?
6.
So how many does sulfur need to be happy?
2.
8, yeah, it needs 2 more to get a total of 8, so it is happy. So it'll share 1 with carbon, and then share another one, and then it'll do the same thing over here. So that's how this one has a double bond. Alright, do you have a question about that one? Alright, what shape is this? Linear. And is it polar or non-polar?
Non-polar.
Non-polar, good, because it'll be the same. Sulfur will probably bring it a little bit closer to it on either side, but since it's the same on both sides, that way it'll be non-polar. So what force is affected?
Just London.
Yes, London. Alright, anyone have any questions about those? That's a good practice for chapter 9 because a good chunk of your test is that.
We're going to take the practice test.
What?
We're going to take the practice test.
Alright, so let's go ahead and let's review chapter 9 and then chapter 8 partly. Alright, we're gonna play Usher Them because there's just YouTube channels and stuff on
How can we play Usher Them
What would we play darts?
I do not have
I
time.
wanted
for
to
cards
play
right now.
the trivia.
Maybe tomorrow if I have more time.
No, I hate
But-
that game.
We're gonna do Usher Them, so we're just gonna go through these really quickly. Be nice to each other, gentlemen.
Yeah, Chris.
Alright, we will
Christopher.
start with Ethan. Alright, Ethan, thinking back over it, we're gonna do chapter 9. So be sure to write at the top of your paper that this is your exam review. Because once we move on after chapter 9, I probably won't come back to it till Friday. So make sure this is your study sheet for chapter 9 to help you to
What is
remember if
Friday?
you need help. Alright, so what is an attractive force between atoms that is strong enough to make your entire molecule act together as a unit?
Say it one more time.
What do you call the chemical force that makes all of the atoms in a molecule stick together?
Chemical force?
Yeah, what's that force? What's that attraction? What do we call that?
I don't know.
Alright, Chris, your chance to steal it.
What is that, force?
Yeah, it's I mean, it's an attractive force that holds the atoms
And
together,
molecular?
that holds the atoms in a molecule together.
We'll start with
C,
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 chemical bond.
chemical bond. Alright, you are,
Almost had that.
Us.
you are Ethan.
Us.
Alright,
Me.
you're little today. Plus 10.
I'm so good at this game.
Alright, there are 3 different types of chemical bonds.
Is it my turn?
Nope.
No, because you stole it, so it goes back to Ethan. Alright, Ethan,
shoot.
what is the most important factor affecting a chemical bond? No threatening people on property, Chris.
See, catch that side, how about that?
If you go outside in the street. Not really. Not really people watching on YouTube, I'm kidding. Alright, so what is the most important factor that affects chemical bonds?
Like just that one, just one side.
I guess V, I guess is the phrase for it.
A V?
V.
Crazy dot?
What was the question?
Make sure you pay attention. What is the most important factor to determine how an element will
Yeah, I
bond?
know it.
Okay.
Valence electrons.
Valence electrons can already
Come
wants
on,
to
dude.
it wants to lose or gain them.
Them.
Them. Plus 50.
This is why you have no.
Alright, what is the rule that says they want to gain noble gas configuration or 8 valence electrons? It's your turn, Ethan.
Oh, sorry, I was off the sauce question.
What is the rule that says they want to get noble gas configuration or 8 valence electrons?
Often.
That is the octet rule,
Chris.
right? Bothers me over on that side. Negative 10. I do mix them up, I'm sorry. Alright, so there are 3 different types of chemical bonds. Which one is characterized by the exchanging of electrons? So one's throwing it, one's taking it.
Ionic.
That is ionic.
Me.
Plus 25. Which one is characterized
Yes, sir.
which one is characterized by sharing electrons?
Covalent.
Covalent.
Chris.
Negative 25. Which one is characterized by delocalized electrons? Nobody wants them.
What's someone wanted?
Which one's characterized, Chris, by delocalized electrons? Nobody wants them.
Delocalized.
Which type of bond?
Metallic.
Metallic.
Me.
Alright, which one is metals to metals? What type of bond is that?
I don't want to play this game anymore.
Metal to metal.
What type of bond is that?
Metallic.
That is metallic.
Chris.
Plus 25. There you go. Alright, what
Now
type
it's
of
negative 75 to go.
Alright, what type of bond is characterized by metals to non-metals?
Ionic.
Ionic.
Me.
Slight reverse, you know how
Oh.
Alright, what type of bond is characterized by metals to metals?
Metals to metals?
Metals to metals.
Metallic.
Oh, I already said, I'm sorry, non-metals to non-metals.
Covalent.
Covalent.
Chris.
Negative
I'm gonna put you in a wheelchair.
No threatening uncle property. Alright, what holds the ionic bond together?
What holds the what?
What holds the ionic bond together? Because remember, one's throwing the electron, one's taking it. What
What's it
holds?
start with?
I guess E.
Any molecular force?
Final answer?
Is that what you're asking?
No. So, if you have...
Oh, the electron. No,
So something like that.
is it, electron configuration?
Accurate. Oh, no. She can still see it.
Is it electrical current?
Close enough, electron charge. Because this one threw off one, this
Me.
one took one, that's what makes them stick together.
Me.
Restart. Restart. Alright. Alright. So thinking about covalent bonds, what do you call it whenever you're sharing 2 electrons, Ethan?
I'm seeing screwed over this entire
Okay, not in my classroom. Not in my classroom.
What?
Okay, what type of covalent bond? Do you need a tissue, Chris? Are you gonna be okay?
No, I like when you have
Okay, cool. This doesn't make it too much.
Nasty.
Alright, so what type of covalent bond is it if you're sharing 2 electrons?
Double.
Final answer? No.
Oh, yeah.
sharing 2,
Sharing 2.
single,
Alright, you're sharing 4?
double,
You're sharing
triple,
6? What?
triple.
Yep, okay. What?
Me.
Plus 100! There you go. Alright,
I'm gonna
Ethan.
get a sign reverse.
What do you call it if you have unequal sharing?
What is unequal share?
Yeah, what do we call it if for a covalent bond there's unequal sharing?
That's what I feel like I'm.
This is solid.
P.
Oh, polar.
Polar. Alright,
Chris.
restart.
my goodness.
Alright, what do you call it if you have billions or trillions of atoms that are bonded together by covalent bond into a large structure? What do we call it, Chris?
What's it start with?
See, we'll play the treasure chest game next. I'm sorry.
Starts with a C?
Breathe, yes.
Is chemical something?
It's covalent bonds into a large structure.
Covalent network.
Good job.
Me.
What's the example for it? Do you remember?
Diamonds.
Diamonds and quartz.
Me.
Alright, let's see. Alright, what's the characteristic of a metal?
Hard.
Well, it's not your turn.
Characteristic of a metal?
Yeah.
Hard.
Alright, so they are malleable, ductile, they're good conductors of heat and electricity, and that's because of delocalized electrons. Okay.
Don't, I swear.
Mate.
-50.
I got 0 now.
Alright,
I win this, I swear.
let's see, we already talked about this. Alright, what do we call a molecule that has a polar bond where it has a positive in and a negative in? So like this. What do we call it?
What's it start with?
D.
D?
D. So there's two sides to it.
D?
D. What are you looking at?
G.
D.
I don't think it has it written on there.
I don't know.
Alright, Ethan?
Delocalized.
Nope.
Delocalization.
Nope. Dipole. Dipole.
I was gonna say that.
Dipole. Alright. We've already gone over this, but I just want to make sure. Alright. Okay, I kind of have to, right? So what do we call this letter that's used to represent a partial positive or partial negative? Back to Chris, since nobody knew. Lowercase delta. Plus 50. Alright, what do we call the drawings like this? What's the name for them? What's the diagrams that are used to show shapes? Isn't that your turn?
Satan's coloring book.
What? No. What do we call this? So where we draw them on the board?
Lewis structure.
Lewis structures.
Grace.
Plus 10. Alright, what do we call electrons that are not locked into one spot?
Delocalized.
Delocalized.
Me.
Hang on, I'm not over there. Back in my mouth. I knew I forgot something when I was in my mouth. Poor Jamie's probably so grossed out. Because she can always hear you. Because whenever I put in my headphones and listen, I can always hear y'all super well. Okay.
Delocalized.
Right. You or somebody else?
Me.
Thanks for that. Alright, what do we call the situation whenever the delocalized electrons hop back and forth between the two spots? Or more?
My dad.
No. No. Don't be depressing.
It's hard not to be depressing when this happens.
So what do you call?
What do you call it whenever the electrons are hopping back and forth between the spots?
Sorry.
D.
Delocalization.
Delocalization.
Hopscotch.
Don't write that on the quiz or exam.
Chris.
Thank you, Jen. Alright, we gotta go over these. Alright, what is the name for this shape? We already got it with Lucy, I just wanna make sure. Hey, what's the name for this shape?
She's put me 7 feet underground, not 6.
0.
Trigonal, pyramid. No, tetrahedral. Tetrahedral.
Tetrahedral.
This is 3 times.
Me.
Negative 20, positive 25. Positive 25.
You go back to 0 again.
Alright, what is the name for this shape?
Trigonal pyramid.
Good job.
Chris.
Sign reverse. I have no idea if you're positive or negative right now. There is enough. There are swaps in here somewhere, so you can give it to Ethan at some point. Alright, what do you call this shape?
Oh, my hard work is gone.
I'm sorry.
Angular.
Angular. We'll play the treasure chest game next.
I don't want to put any more names. I just write the right facts.
Okay. Alright, Ethan's turn. What is the name?
It's my name.
What's the name for this shape?
Nothing. It's funny, huh? I know where you live.
Trigonal. Fire. Me.
Plus one. What's the name for this shape?
Let me see it. Linear. Me.
Negative 50. Alright. We've gone over the 3 different forces. What type of force is the weakest, Ethan?
My will to live.
Sorry.
Which one is the weak?
Which one's the weakest?
Which intellectual force?
Which molecular force is the weakest?
Is London.
Alright. Chris or somebody else?
Me. Me.
Alright. Swap points.
Take this negative 100, boy. Take my negative 100. What do you got?
You have negative 85. No, yeah, you have negative 85.
Alright. We're
Now
gonna
you're negative 100.
Alright, we're gonna choose just one more card because one of these is a swap and one of these is not swap, but to keep it fair so that way Chris just doesn't get his points back at the very last because that's depressing. So, we're only gonna do one more card, so it's your shot to the next person. Alright, so I think it's Chris's turn. Alright, Chris, what are the molecular force is the strongest?
Hydrogen bond.
Hydrogen. Alright. So,
Ethan.
this is the next card?
Ethan.
Alright, this is the last one.
Ethan.
Swap.
You said that we took swap out.
No, there's only going to be one more card, so swap or the other one, because I didn't want you just to automatically just get swapped up and automatically lose. So I'm sorry. Hey! Let's move on to this one. I'm sorry, Chris. Alright, we went over
Am I a
which
joke to you?
forces. I'm sorry. Well, we went over which forces go to which one already, so we're gonna move on from that one. Alright, there are two different types of solids. What type of solid has a regular repeating three-dimensional pattern? Chris, would you like to start with what make Ethan go?
Can I just write facts, please?
You may write facts. Alright, Ethan.
I'll go. You know what? I'll do it.
Okay.
What's the question?
Alright, there are two different types of solid. The type of solid has a pattern in a three-dimensional repeating pattern. Ethan, breathe!
Let's just start with
C.
crystalline.
Crystalline.
15.
Alright, what's the other one, Ethan? Where it doesn't have that repeating three-dimensional pattern.
Chris, it's your turn.
No, it's Ethan's turn!
No, no,
Okay.
Morpheus.
Amorphous.
11.
Write it down, Ethan, so I hope you remember to study. Alright, what is the simplest repeating unit in a crystal? Ethan, do you want to go? Okay.
36.
You're crying. He's legitimately crying.
Alright.
You got reset and switch so many times.
I
Alright.
don't want to talk about it, dude.
What is the simplest crystal system? It's the dice. What is the simplest crystal system? Cubic.
28. If he wins this round, I'm literally gonna commit
Nope.
kamikaze.
Nope. Alright, so there are two different types of post-packing. What are they? We'll name one. Leave it at.
Face. FTC.
What's that stand for?
FTC.
Face centered cell.
Face-centered cubic, and then it is the
Hexagonal.
closed-packed system, or the closed hexagonal closed-packed. Okay.
16.
I feel like I should get candy for most of the summer.
You might. Alright, what do you call it? What type of crystals is it whenever they're able to move freely in one direction, but they still have some amount of rigidity? What do we call that? L.
L.
It's like soap bubbles, your TV screens,
Liquid crystal.
it does.
Wait, liquid bubbles are liquid crystals?
Technically because they're
13.
still flexible, but they can't go everywhere.
13.
Was that 13?
Yeah.
Okay. That is
Thank you.
predominantly
Thank
chapter
you.
9.
Thank you.
Not there.
Ethan,
I
isn't
know
that
it's
it?
not
Ethan,
there.
isn't it? Ethan.
Yes, it is.
Well, it really is. I'm not joking. I swear I'm not joking.
You're lying.
I'm not joking.
Alright, so thank you back over it. So that's pretty much chapter 9. So we're
I
back into
really
chapter
dislike you
8
right
now. Alright, what do we call it that alright,
How
what
does
is the
man still
law?
win and he only gave it to himself twice?
I'm
not gonna get over that.
Alright, so what is the law that says that the first is like the 8th, the second is like the 9th, so it's that same repeating pattern every 8? What do we call that
We'll
law?
start with
Law of and then O.
law of
Think music.
octave.
Octave.
23.
Why'd you say it like that?
Alright, what is the law that says that the physical and chemical properties of the elements are periodic functions of their atomic numbers?
Periodic law.
Periodic law.
You make me sick.
34.
Alright,
I feel
so
physically ill.
what do you call the up and down
Columns.
And then, okay, so like in math it's column, what do you call it in period table?
Row. Well, let's start with period.
G.
G?
G.
G?
Yeah, like we don't say column one, what's the name for it?
Group.
Group one, and then what's the back and forth ones?
Row. Period.
Periods.
5.
You have 5 zeros.
Let's see. Alright.
Stop
Alright, what is
talking
the
to
name
me.
for group one? You just have the giggles now. Alright.
Alkali.
Alkali.
17.
Alkali. That was a stupid game.
Alright. I'm sorry. What is the name for group two?
Huntington.
Girl.
Alkaline earth metals.
Alkaline earth metals.
21.
Good job.
I finally won something.
Yeah.
I finally found something positive in my life.
I must all those negative numbers you were getting.
Ethan?
Ethan just has the giggles now. Just breathe, Ethan.
He has
Alright.
asthma. He doesn't know what breathing is.
Alright, we'll go back to Ethan since Chris won. Alright, Ethan, what's the name for group 16?
Starting to see?
Yes.
Calcogens.
Calcogens.
21.
Alright, what is the name for group 17?
Halogens?
Halogens.
13.
13.
Complete. This is.
Alright, what's the name for group 18?
I'm not mad. I'm not angry.
Double guess.
I'm disappointed.
36.
My disappointment is measurable. My day is ruined.
Alright, nobody else will make it up for that one. Alright, we'll have to go over electron configuration a little bit later once we do the practice sheet tomorrow for that one. Alright, I was thinking about the periodic table. You still can't. I'll try to see if you can slide it over, David, so that way you can see it a little bit better. Okay, at least you can kind of see it now. Alright, so thinking back over it, what corner of the periodic table is the largest, Chris? So, top left, bottom left, top right, bottom right. Which corner of the periodic table? Which one?
Bottom left.
This corner?
Yes.
Which corner is the smallest?
Top right.
Top right. Good job. Choose your number.
17.
What?
17.
It's so sad.
Alright, so, alright, which one has the smallest ionization energy? What's ionization energy first off?
Remember.
Hope you can hear me, Jim. What's the smallest ionization energy?
She said, what's the smallest ionization energy?
I do not remember.
Alright, do you remember?
Ionization energy?
Yeah, which
Where
one has
is
the smallest ionization energy?
I know which one is the biggest.
Alright, which one has the biggest?
Fluorine. That's electronegativity.
Okay.
Ionization energy, what's the smallest?
Alright, think of this, what is ionization energy first off?
What was the question?
Okay, the question is which corner has the smallest
Bottom
ionization?
left. Yes.
Why?
Because ionization energy is the opposite of what the other thing was.
Alright, you're right. So, ionization energy is the idea of electrons pulling them off. So, do the metals down here want to lose their electrons? Yeah, so it'll take a lot of energy to pull them off. No, so that's why down here it's the smallest. Up here it's the largest. Why is it the largest in the top, Chris? Top right.
They don't want to lose their electrons.
Yeah, they don't want to lose them. How come that one has the largest ionization energy? Because they go, no, and they don't want to lose them. Alright, choose your number.
5.
Alright, Ethan, which one has the most metallic character? Which corner? Top left, top right, bottom right.
Top right.
Has the most metallic character?
No, bottom left.
Bottom left? Final answer?
Yes.
Why? You are correct, but why?
Because he guessed.
Probably, but why?
Because I guessed.
Alright, so the definition of metallic character is having low ionization energy. So what corner has the lowest ionization energy?
Top left.
Oh, okay.
Bottom left.
Bottom left. So this one has the lowest ionization energy. It has the highest metallic character, or they're most like the metals. So up here, they're least like the metals. Alright, here's that.
16.
I can't do that. I'm gonna move it down here. Alright, Chris. Which one has this is a little bit weird one. Which one has the most negative electron affinity?
The less?
The most negative, because remember, electron
Like what
affinity,
element?
which corner, so top
Top
left,
right,
why? You are right, but yes.
cause fluorine's up there, that's all I know.
Alright, so electronegative, no, okay, so you're thinking electronegativity, electron affinity, which one has the more negative electron affinity?
Oh, because the top right are gases.
Okay, close enough, it's the idea of electron affinity is what? Do you remember?
No.
No.
Alright, adding electrons, electron affinity. So if they are the more negative, that means the more stable they are. So which corner is stabilized by adding on electrons?
Top right.
Top right. That's why up here this one has the most negative or the most stable. Down here, least negative or least stable. Okay.
1.
Alright. What element? Alright. What element? I'm sorry. This is just the next question. What is the next?
Have a toothpick.
No.
I'm not gonna shank him, I like chewing my toothpick.
He's going to say me because that's the first thing you mentioned.
No, cause I know that's what she's thinking.
No. Alright. What element has the highest electronegativity?
I just chew on your toothpick.
What element specifically? Highest element. Has the most electronegativity.
I've said it like 8,000 times.
It has been a lot.
Sorry?
Fluorine.
You're a failure. 20.
27.
Alright,
Number 6.
So, what is electronegativity, Chris?
How negative a number is.
Yeah, geez.
How small the cloud is.
Alright, Ethan, do you remember?
How large their
Yep.
clouds are.
Alright, so write it down. Electronegativity is the ability of chemically combined atoms to attract electrons to themselves.
I'm not
Basically,
using this paper.
so basically it's like an addict, basically saying, okay, how much, how much it wants to get electrons to itself. So it's because of that, fluorine is the most electronegative. Which corner, if fluorine's not an option, is the most electronegative? I think it's Ethan's turn.
No, he just,
I don't know.
he guessed and then it was wrong, so it's my turn now.
Okay.
Top
You
right.
guessed it?
Top right.
Top right?
Yes.
Yes.
Let me get 3.
Alright, so, speaking about cations and anions, if I were to have something like this,
Can't wait. Your last 2
alright,
minutes or
which
something.
one, I know, I'm about to be done. Which element is smaller?
G2 plus.
Why?
Because it's losing electrons.
Yep, you're right. Alright.
I'm losing my little wood.
19.
Alright, what if it's something like this? Oh, I need to move the camera over here. Yeet, sorry, Judy. Yeet. So, between these two,
Oh,
this
2
one's the
negative.
smaller one.
Oh, negative 2.
Which one is, I said, did I say smaller or larger?
Smaller.
Which one's the smaller?
Oh, 2 negative.
Why?
Because it has more electrons.
So the electrons will go closer together?
No,
or
there's
there's more?
less.
Yeah, so this one is the smaller one because electrons will shimmy out away from each other.
29.
So, hang on, so wait, Jamie, no. So if you have an anion, the anion is slightly larger than the neutral one. With the cation is slightly smaller than the neutral one. Alright, homework for tonight. That's pretty much all of chapter 8 at this
No
idea.
homework?
No. Chapter 6. Chapter 6 review. Alright, questions 1 through 12. You can do all of them. Questions on it's the chapter 6 review. I said chapter 12 review, didn't I? Chapter 6 review. Questions. It starts on page 91 and goes over to the top of page 92. 1 through 12. All of them. So chapter 6 review. Questions 1 through 12.